All right, our other reaction that we need to be familiar with is fusion. So fusion is combining light nuclei to produce something heavier. Your fusion example that you're always going to see is hydrogen plus hydrogen make helium. Now you might see a different isotope of hydrogen, but it's going to be hydrogen plus hydrogen makes helium and an insane amount of energy. So fusion is the reaction that occurs on the sun. So the sun obviously produces a huge amount of energy, so fusion produces a huge amount of energy. This also would be the hydrogen bomb. Now, fusion releases an insane amount of energy by producing helium. Helium is not highly radioactive. Helium is not scary. So fusion could be our perfect reaction to give the entire world a cheap form of energy. So products aren't highly radioactive, produces insane amount of energy. However, the problem with fusion is you are literally trying to fuse together two hydrogen nuclei. Both of the nuclei are positive. They don't want to fuse together. So this reaction has to happen at such a high temperature that we can't produce it on Earth without all of the materials melting. So it's got to happen at such a high temperature that we can't have a fusion power plant. So this is something that they're constantly working on to try to make a fusion reaction that could happen at a more manageable temperature so that fusion could actually be done to produce energy. All right, another thing that's not going to be on any test or quiz, but something that you should have some general knowledge about is nuclear bombs. So we know that nuclear bombs are way more destructive than a TNT bomb. So it uses a nuclear reaction. And when they say the atomic bomb that uses fission, either uranium or plutonium, and a hydrogen bomb would use a combination of both. And a hydrogen bomb using fission and fusion is 1,000 more times powerful than the regular atomic bomb that uses fission, that was used at the end of World War II on Hiroshima and Nagasaki. So that was hugely destructive. The hydrogen bomb would be even more destructive than that, and luckily that has actually never been used in warfare. The reason why the hydrogen bomb uses both fission and fusion is, remember, fusion is really difficult to initiate. So the fission reaction happens first, providing the activation energy for the fusion reaction. The two times that a nuclear bomb has been used were at the end, towards the end of World War II. In 1945, the United States dropped a uranium-based fission atomic bomb on Hiroshima, and that leveled approximately 5 square miles, killing 80,000 people instantly. And then tens of thousands died later from radiation poisoning, and then also increased risk of certain types of cancer, risk to wildlife. Then 3 days later, the United States dropped the plutonium-based atomic bomb on Nagasaki, and that one killed approximately 40,000 people, and then again more people later on. So both of these were fission based bomb, so plutonium or uranium. And then luckily, the hydrogen bomb has never been used in warfare because that would be even more destructive. All right, so you need to recognize fission, recognize fusion. So fission is neutron plus uranium or plutonium splits into two mid-weight nuclei plus some additional neutrons. That is used in the atomic bomb and in nuclear power plants. Fusion is hydrogen plus hydrogen equals helium, and that is the sun. So those are the main things that you need to know about fission and fusion. You need to know that fusion releases the most energy, then fission, and all of our nuclear reactions release more energy than regular chemical reactions. Specifics on nuclear power plants, nuclear disasters, on atomic bombs is just to give you a little bit of background information. Had we been together in class, these are some days that we would have had some really good discussions on those things. There's some movies that we would have watched. But I want to make sure you have some general knowledge of these things that you might hear about.